Rational Expressions Part 2. And so we're going to continue to work with rational expressions. Before we multiplied and divide, now we're going to be getting more into adding and subtracting. Here we have two fractions. And so whether we're adding rational expressions with numbers like 1/2 plus 1/3, or rational expressions that involve polynomials, the process is the same. We need a common denominator, right? So here we have a b, but we don't have an e. So the first rational expression, we need to multiply e over e. Well, the second rational expression has an e, but it doesn't have b in the denominator. So the second rational expression, we've got to multiply b over b. So the first fraction is ae over be. Second one is cb over be or eb, same thing. So we put the be under one denominator, and then we put the ae plus cb all together in the numerator. So the process is no different as to what we've been working with numerical fractions. Subtracting, the process is the same, except for instead of having a plus here, we've got a minus. Now the only thing is, you're still going to get a common denominator here, and you're going to get one denominator, common denominator here. But with polynomials, you have to be careful, because this minus here, you may have to distribute that negative if you have something other than a monomial there. So if you have a binomial where there's two terms, unless it cancels, you're going to have to distribute that negative. All right. So that's something that students tend to have some trouble with. All right. Complex fractions. Here we have 1 plus 1 over x and 1 minus 1 over x squared. You look for the least common denominator between the two rational expressions. So this could be looked at as 1 over 1. You put like a denominator there. So you look for the least common denominator, which would be have an x squared and an x. So the least common denominator between these two would be what? Since we have x and x squared, our least common denominator would have to be at least a what? Well, if we need to get a common denominator between these two, right, we have a 1 here, but we have an x squared here, but we don't have an x squared in the denominator, so we'd have to multiply x squared, right? So x squared is going to be the least common denominator. So we have to multiply x squared into the entire expression. And so we would distribute this x squared into both. Okay, and then when we do, and same thing in the denominator. And so we distribute the least common denominator into both the numerator and denominator. And then we get here the x squared multiplies times 1, that's x squared. X squared, the x and the x squared cancel, and you're just left with the 1x here. Here the x squared multiplies times 1, that's x squared. That's this x squared here. And then x squared cancels an x squared, and what's left? Just the 1. And so from that should be a 1 there. And so we factor out the common factors and we simplify. Oh, I know what it was. We have to distribute. We have got x squared, so it'll be x plus 1 and x minus 1. All right. So let's take a look at some problems from that. then let's say that we have, to start with, 8 over 5p plus 3 over 4p. Alright, we're trying to add. So think of it like this. If we just had just new numbers, like 8 over 5 plus 3 over 4. If we were just trying to add those, no p's, right, we would need a common denominator here, which would be what? 20, right? So that means we would have to multiply, here we have 5, so we'd have to multiply 4 over 4 here. And so that'd be 8 times 4 is 32 over 20. And then here we have to multiply 5 over 5 and get 15 over 20. Okay, and then from there we can add 5 and 2 is 7, and that'd be 47 over 20. Well, the process is the same here. There's no different. We still need, we have a p and a p, but we need a 20p. So we have to multiply, we still have to multiply 4 over 4 here, and we get 32 over 20p. And then here we have to multiply 5 over 5, so we get 15 over 20p. So that gives us 47 over 20p. Okay, and that's our answer. If we can simplify this, we want to, okay? But there's nothing that only factors for 47 are 1 and 47. So we're done with that. Okay, so just to look at it, keep in mind the process is the same as it always has been with just numerical fractions. Okay, it's no different. All right, questions with that? Okay. Here we try this. We have 7 over 18. A cubed b squared minus 2 over 9 ab. Okay? All right. Travis, what would you do here? Okay, 9. We can get. Let's look at 9 and 18 first. Let's look at the coefficients. All right. What common denominator can we have between those two? 18, right? So here we'd have to multiply what?
2a squared b.
Yeah, that's right. You're going to multiply. That's right. You're going to multiply 2 over 2 for the. And then here you have an a cubed and an a, so you got to multiply a squared. So that'll be a squared over a squared. And then the b, here you have b, and here you have b squared, so you got to multiply b over b. All right, good. So that gives you, we don't have to multiply anything in the left term, right? So that'll be 7 over 18 a cubed b squared minus 2 times 2, that'll be 4 a squared b over 2 times 9, that's 18 a cubed b squared. So altogether we have one common denominator, right? 18 a cube b squared. And once you establish the same common denominator, I like to write that first. That way you don't have to mess with that anymore. And then just rewrite what you have in the numerator. And so that would be 7 minus 4a squared b. And that's it, right? If we can factor, if there's a common factor that we can factor and cancel, if we can add them, we can, and then see if we can simplify from that. But that's all we can do there. All right, any questions with that?